In electronics, gain is a measure of the ability of a circuit to increase the power or amplitude of a signal from the input to the output by adding energy converted from some power supply to the signal. It is usually defined as the mean ratio of the signal output of a system to the signal input of the same system. It is often expressed using the logarithmic decibel units. A gain greater than 1, that is, amplification, is the defining property of an active component or circuit, while a passive circuit will have a gain of less than 1. The term gain alone is ambiguous, and can refer to the ratio of output to input voltage current or electric power. In the field of audio and general-purpose amplifiers, especially operational amplifiers, the term usually refers to voltage gain, but in radio frequency amplifiers it usually refers to power gain. Furthermore, the term gain is also applied in systems such as sensors where the input and output have different units. In such cases the gain units must be specified, as in 5 microvolts per photon for the responsivity of a photosensor. The gain of a bipolar transistor normally refers to forward current transfer ratio, either HFE, or sometimes HFE. The term gain has a slightly different meaning in antenna design. Antenna gain is the ratio of power received by a directional antenna to power received by an isotropic antenna. Logarithmic units and decibels, power gain, in decibels, is defined by the 10 log rule as follows. Where pin and pout are the input and output powers respectively. A similar calculation can be done using a natural logarithm instead of a decimal logarithm, and without the factor of 10, resulting in NEPAs instead of decibels. Voltage gain, when power gain is calculated using voltage instead of power, making the substitution, the formula is. In many cases, the input and output's impedances are equal, so the above equation can be simplified to. And then the 20 log rule. This simplified formula is used to calculate a voltage gain in decibels, and is equivalent to a power gain only if the impedances at input and output are equal. Current gain, in the same way, when power gain is calculated using current instead of power, making the substitution, the formula is. In many cases, the input and output's impedances are equal, so the above equation can be simplified to. And then. This simplified formula is used to calculate a current gain in decibels, and is equivalent to the power gain only if the impedances at input and output are equal. The current gain of a bipolar transistor, HFE or HFE, is normally given as a dimensionless number, the ratio of it to IB. In the cases above, gain will be a dimensionless quantity, as it is the ratio of like units. In the bipolar transistor example it is the ratio of the output current to the input current, both measured in amperes. In the case of other devices, the gain will have a value in SI units. Such is the case with the operational transconductance amplifier, which is an open-loop gain in Siemens, because the gain is a ratio of the output current to the input voltage. Example, Q. An amplifier has an input impedance of 50 ohms and drives a load of 50 ohms. When its input is 1 volt, its output is 10 volts. What is its voltage and power gain? A voltage gain is simply. The units VV are optional, but make it clear that this figure is a voltage gain and not a power gain. Using the expression for power, P equals V2 per Rankine, the power gain is. Again, the units WW are optional. Power gain is more usually expressed in decibels, thus. A gain of factor 1 where both input and output are at the same voltage level and impedance is also known as unity gain. See also, active laser medium, antenna gain, aperture to medium coupling loss, automatic gain control, attenuation, complex gain, DC offset, effective radiated power, gain before feedback, insertion gain, loop gain, open loop gain, net gain, power gain, process gain, transmitter power output. This article incorporates a public domain material from the General Services Administration document Federal Standard 1037C.